Everyone? Yes, yes. Thank you for that confirmation. So let us start from where we have left the previous Kubernetes session. Okay. Okay. So what we have learned that we have a cluster, Kubernetes cluster, because this cluster is going to deploy our applications or over which we are going to deploy our applications, mostly the containerized microservices. Okay. And that is what we call as pod. Anyway, to understand that, we have understood the architecture of how this big cluster is managed. So we have installed, uh, there are three nodes. One is the master, and there are two. There can be two, there can be three, there can be 10, there can be 20 worker nodes. It depends on how much load you want to distribute between the application and how your solution architect is or the architect is designing the infrastructure, based on which this information will be given to you, and therefore you will implement that Kubernetes cluster accordingly. Is that fine? And while we discuss, it should not be a one-way traffic. It will be better if you can also ask questions, give some suggestions, or basically interact. That will make it very, learning a very fun process. Learning should not be a botheration. Otherwise, we will not learn. And learning, we should not learn with the basic motivation of getting a job. The thing is, the job will fall in place if your learning is complete and correct. Okay, both should complement each other. That means one is meant for the other. So knowledge, which is a good knowledge, if that is developed, you are sure to get a good job. So there is no shortcuts. When we learn master, that Kubernetes master was installed with few of the components, and these are the mandatory components that is already installed with the installation of the cluster. In the master, we have seen that there is kube controller manager, kube controller, a cloud controller manager for interacting with the cloud. Otherwise, there is always the kube controller manager, kube API server, which is the main component, along with the HCD. HCD, you can see, is like a database which stores a key value pair. It's a key store. That means whatever is happening within the cluster, whether good or bad, every health information is collected and stored over the etc every moment. That is the big mechanism of how the API server comes to know, because API server is the brain of the entire structure, architecture. This API server will come to know, consulting the HCD, what is the current state, what is the desired state, and what is the current state. If there is a difference between the desired state and the current state, it will immediately spring into action and get it corrected. Okay. So therefore, API server will interact with its HCD to get a knowledge of the state of the cluster, and thereafter it will use the kube scheduler, the kube proxy, as well as the kube controller manager interact with the worker nodes to find out what happened and what should be, how to correct the situation. So on the worker node, we have seen that there are two very important components, kubelet and kube proxy. Kube proxy is the network. The communication over the network will be conducted through kube proxy. Kubelet is a manager of the pods which are running in the node. So the node will run the pods. Pods are nothing but the applications which are contained, or the microservices which are inside the containers, right? So there will be an abstract layer. We will learn about the pods. So we come to that and say that kubelet will get the health of the pods which are running, which are desired. And if there is something which is not up to the liking, or something is too much loaded, the node may be too much loaded. So all this information will be carried over to the API server through the kube proxy. So each of the nodes, the worker nodes are the persons or the people where your applications will run. These are the servers. These are the nodes. They are in the same cluster. And there is a pod network running between each of the nodes along with the master. So over the pod network, there will be the communication. As we had a detailed discussion over that in our previous session, if you can remember. Okay. So this is an overall scenario, or not the scenario, the structure, where you have the master node with the Kubernetes components like etcd, API server, scheduler, and the controller manager. Can you see the controller manager? All the communication between the pods, between the nodes and the master node will happen through the controller manager over the kube proxy, which is the network element. Okay, so that communication happens. But again, I'm saying API server is the most important part, because everything will come to here from outside, from internal to the cluster. Everyone will interact with API server. API server, then this is the super boss manager, the program manager, you can say. And the controller manager is the project manager. So it is the program manager, the controller manager is the project manager. Okay. So everything will be communicated between the program manager and the controller manager. So the program manager will be the owner of and responsible for running the cluster smoothly without any issues. So on the slave nodes, which are worker nodes, and another thing, you must have Docker, because after all, these are also pod. I will show you at the very end of the session. I will just go to discuss a bit of so that it is not in the scope to have a good number of hands-on to go through some examples, but that is in scope of our full-fledged training. But I will ensure that you at least know what is happening. I have a cluster enabled just for the sake of this session. So you will see that these are pods which are running when the cluster is up. So API server is a pod, etcd is a pod, scheduler is a pod, controller manager is a pod, but they are getting managed with the help of Docker. So we have to install Docker for all the nodes. I'm saying Docker, it can be any other container software, which is the container management software, which can be Mesos or Rocket. But you cannot compare them with Docker. So Docker is so popular. On the slave nodes also, we need to install Docker. The installation process is itself a huge number of steps are there. Not huge, I will say, but you have to be very careful. You cannot miss or afford to miss any of the steps. Okay, you have to plan it very well. So I discuss and document each and every step and give it to our students. They practice it and they become almost like a very confident person. Because see, Kubernetes is not simple, to be very frank with you. That's why in our main course, what we do, we keep the Kubernetes project, Kubernetes, after we have done the capstone project. So in the capstone project, we do all the things like the Git, the cloud, the AWS Cloud, then your Linux. Of course, everything is based on Linux. And then we have the Docker, we have the Ansible, we have the Kubernetes, we have, of course, a pipeline with GitLab. So all these things will be integrated. They will be streamlined on the pipeline of GitLab. And we conduct a we complete a capstone project. That capstone project gives a lot of confidence to our students, after which they now step into Kubernetes. So at that point of time, we have found out from our studies with several batches that that is the best way. I cannot start with Kubernetes in the very beginning or somewhere in the middle, because it won't be possible for students to assimilate the knowledge part of it. So on the after the Kubernetes cluster has been installed, you will see that the nodes have the slave nodes, the worker nodes will have the Docker. Of course, the Docker will be there because the kubelet, the kube proxy, again, they are the pods, as well as you will run the actual pods, the application pods over on the slave nodes. Any question that you might have? Or can I proceed? Yeah. So
Yes.
yeah. Thank you.
Yes.
So you see,
I do have a question. Sorry.
yes, please.
Could you please go back to the previous slide? I just want
Yes.
to. Okay, I do see that the API server does form or work rather as the heart of
Yeah,
the
heart.
cluster.
Yes,
Is that correct?
yes, that is the heart.
Okay.
If that is the
So,
heart, then I will say HCD is the brain. Someone has to be
okay.
there with the brain. So whatever, if you say this is heart, then this is the brain. I
Okay.
actually told that this is the brain and this is the heart, where all the core information is stored for the cluster. Anyway, it's interpretation based.
Okay, but it
Yeah,
makes sense like this. Okay, I do see the API server is the heart. Because I was just trying to connect
yeah,
it with, because generally when we refer to an API, we use it to fetch information from a server. So now, if it's an
yeah,
API server, is it
yes.
integrated with the API technology, but it's a server?
Exactly. And if I
Okay.
could have shown you the manifest file, okay.
Mm-hmm.
So in the manifest file, you have to mention, uh, like the manifest file is the deployment. Deployment is a manifest file. The service is a manifest file, because they are what you desire. What is more important? So what we write is some YAML files, very simple and according to the structure that is designed for Kubernetes. So these are manifest files which are giving instructions or desire of what is needed. So Kubernetes API server can read those manifest file and do the actions accordingly. I will show you one manifest file.
Okay.
So in
Okay, then
other
you will
words,
understand that these are API calls. Yes, of course. So the manifest file is an object. So that object will interact with the API server, or API server will interact with the object if the object is running with the API calls. So because the API calls are also, it is sort of a REST API. So it can, a REST API means something which is transactional based. So it can interact with the outside world also.
Okay, I see.
So did you understand? It is not only that the internal requests and calls will be catered to with the API server. The API server has a function to interact with the outside world as well, because all things, all queries, all requests should end up. This is the basically the endpoint, the API server. From API server, then there will be a discovery of the service. That means if you do not have a service that can find out the pod, okay, pod means the application, then out of hundreds of application running, you will not be, you will take a lot of time to get to a particular service. So there is the design. The design actually is so versatile that you do not need to worry. You need to be transparent. You have been given an endpoint. Okay. So you will go for that URL. You will call, you will request, you will have that request through the URI or the URL. It is not URI, because when you interact with the browser, it is URL. locator, uniform resource locator. So you are locating the resources, whatever resources that you need over the browser. And the browser is an external entity. So the request will come to end up with API server. Yes, there will be a technology of load balancer and a reverse proxy server and an Nginx,
Right.
ingress controller. Ingress controller will act as a, as a filter between your external, because for the security, just now Karthik was saying, Mr. Karthik was saying about cyber security, DevSecOps. So in that DevSecOps, we need to the assets or the resources that we are maintaining over uh, in our cluster or in the pipeline. We can deploy the pipeline over the cluster or the Kubernetes cluster. But whatever we do, these are the various jobs, the various processes that need to be secured. So that because of those security, we will not reach our endpoint or the APIs, the services directly from outside. That is a security breach. We need to do it through some ingress controller. That is why it is called controller, which can act as a load balancer, reverse proxy, so many things for all security measures. So did I answer your question?
Yes, and that would be the kube control manager, right?
See, this will come from outside to API server or from inside to API server. Through the controller manager, it will go to the respective nodes and the respective applications or the pods. So controller manager is sort of a interface between the nodes, the worker nodes and the master node. Anything coming in the master node or going out from the master node is through the controller manager. Now, when I say controller manager, is not one single controller. There are so many other controllers we will come to know. So each controller will have that specific function. Then there is a replication controller. Okay. So a replicator, a replication controller, that is also controlled by the controller manager. So if there is some replication issues, that means you desired three replicas of a pod, okay, of an application, but somehow that one pod got down, deleted. So immediately there is a loss of one pod. So that pod has to be immediately replicated back to a state of 3 instead of 2. So that information, all those things will originate from the kubelet. Through the kube proxy, it will go outside this slave nodes and come to the controller manager. Controller manager will validate that request and give it to the API server. After that, API server will consult the etcd whether what was the desired state. Now I'm getting a information. The API manager will talk to etcd that, see, I have gotten information that from the control manager that there is one particular node where instead of 3, that there are 2 nodes working. There is a loss of one node, one pod. So can you check whether what is desired? So then etcd will check the database and give it back to API server. Yes, it has to be 3 or 5 or 7.
So does
you
etcd,
please take, yeah. Yeah.
I'm sorry to interrupt.
No problem.
So does etcd check the blueprints of the YAML file, or what file does it check to recognize that the blueprints that were supposed to be 3?
Yeah, so very good question. Very good question. When the blueprint was created and implemented, let's say deployment is a blueprint, better to say manifest file. Okay. So the declarative script. So that was created by you as a DevOps engineer. Okay, and then you have put that into as an object of the cluster, of the Kubernetes cluster. So that object, when it was created and it is running, so etcd has already got that information from that particular manifest file and it has stored into its database. So unless and until you change that manifest file, let's say today or just now, you have implemented a deployment of certain application where it is required to have 5 replicas. Okay, once that deployment object is running in the background in the cluster, immediately HCD will be able through the API server, it will be able to basically everything will interact with API server. So that information that there is a deployment object, okay, with which has created the pods, and there is a set of replicas needed. Okay, that information will be given by API server, and it will be asked to store in the HCD. Then API server will forget about the information. There is no point in there is a sort of process and forget. But this HCD will always remember because it has the data. So whenever that particular pod deployment that was attached with a service, now that is somewhat either less or more. That is, more is also not expected. Somebody has created a pod manually, so the number of pod has gone up from 7 to 8. Okay, that is also not desired. So immediately the HCD through the help of API server will delete that pod, drop that pod, because you did not desire in your deployment manifest file, you had only desired 7 pods. So you should not be having 8 pods. That is a breach of agreement.
Okay.
Okay.
I see. Thank you so much.
So in turn, API server will talk to scheduler. All these are API calls centered around or pivoted around API server. So it's a very good component, very important component. To see that there is the Linux or the node components can be on the Linux as well as on Windows. It can be a combination of the platform. Platform is not very important. But generally, because most of the servers in your organization will be on Linux, so generally there is the percentage of occurrence of having a Windows server is very, very less. Anyway, if that is so, even that's not a problem. But you always have the master on the Linux server. A node should be created which is absolutely Linux, because master should not be on Windows, because your master has to run day in and day out with the availability almost 100%. So anyway, this is the master node, and you have the Kube API server. Everyone is connected to Kube API server. HCD is talking to Kube API server. Kube API server is talking to the scheduler, and scheduler is talking to the controller manager through the API server, and that happens. In the node part of the worker node, you have the kubelet, the container runtime engine, and the kube proxy. Yeah, I have missed out the container runtime, but that is understood that these are also pods. These are also containers running inside the cluster of the master node. So there has to be Docker, a container runtime, CRI, container runtime interface. So here there also be the same container, I mean the container runtime engine or interface. And of course, you have to have kubelet and kube proxy. Kube proxy, can you see that this is connecting to your pod network? A pod network is running throughout the cluster. Now, we will start with HCD. As I told you, we have already discussed HCD is the key value store. It is like a database. It will store all the information, the cluster-wide information, as well as the secrets. If you have some password, some config file which you do not want to expose to the external world, all these things will be stored under HCD. Okay, because there will be lots of sensitive information. That sensitive information you should not, only one person can access that. Who is that? It is the API server. No one else, scheduler, controller manager, your kubelet, kubeproxy, no one can have an access to HCD. It is so much protected. So it is a database. Basically, it's a database. Is the most important component of master node. All the configuration changes that we are making, all the deployments being created, all the scaling operations being performed, all the details of those are stored in HCD database. The desired state, that is very important. As a user, as a DevOps, as a customer, that means my corporate is the customer and they have desired some architecture. So that is very important because that desired state has to be maintained. Therefore, it has to be stored in the HCD. So HCD, it is recommended that you should not have one pod of HCD. It is recommended that you should have 3 to 5 replica sets of this HCD because it is the most vital part. If you have one and that one goes down, what will happen? After all, this is also a pod. All Kubernetes cluster configuration details, secret keys, the passphrase, the SSL keys, okay, your TLS certificates, all these things will be stored over into this HCD. Passphrase, that passwords, etc. stored in HCD. Nobody will have an access to it as per the design. It can only be accessed by the API server. One cannot access the HCD. Yeah. Now coming to the next vital component of Kubernetes is the API server. As we
Mr.
said,
Debashish,
yes.
Mr. Aniston, I have questions.
I cannot see it. So can you tell me what the question is?
Oh no, he raised his hand, so he can go right ahead and ask.
No, you can go ahead, Alex. I'll ask after you.
Okay.
Oh, okay.
Thank you, Alex, for this coordination. Thank you very much.
No problem.
Okay.
I do see that pods can fail, right?
Yes, very much.
But now
very much.
my question was, what would necessarily kill a pod?
What will necessarily
kill a pod? What causes a pod to fail?
Generally, it is expected because you have deployed over the cloud. Let's say you have deployed the Kubernetes over the cloud, that is AWS Cloud. As it is, you have ensured every availability and stability, consistency of the applications over the pods will be very much according to your desire. So they should not fail. They will not fail. But in case, see, you cannot assume that that is an ideal happy planning. You should not go for a happy planning. We should plan for the worst case scenario. Let's say what happens if, yeah, I know it won't fail, but what if it fails? So I cannot take that risk. So therefore, I will say that I am not happy if then I am at a risk. See, any hardware, any software, any component is vulnerable. That means it can always fail. If assume that there is a huge load, suddenly there was a surge, there was a DOS attack. Okay, that could be a good use case where a pod can fail. It couldn't handle that much of processing, the load. Yes, you have sort of load balancer and auto scalability and all those things in place, but still sometimes do happen. It can crash. Even the node can crash. Even if you have a RAID implemented, a node can crash. So what if that happens? So our cluster should be so robust that it should take care of each and every fatality that it can happen. We should not plan for anything with the assumption that it is good, but it will not fail. No, that is a wrong assumption. It can fail, and you have to plan for that. That is why these are so important, that to understand that if you have one HCD, one pod running, it is not a good design. So you can go back to your architect saying that, see, I know in Kubernetes, HCD will not fail, but at least we should have at least 3 pods of HCD. So can you allow me to have that replication of 3 pods of HCD? Architect may not be aware of, see, architects are always not very much aware of the technology. They are very good at designing your structure of because they are experts in judging how much load will be there, how many requests per second will come into the system, because they over the years of experience, they understand that during the peak time, this is the load, during the off peak time, this is the load. How you will auto scale up and auto descale. So all these things are the domain of an architect. They will suggest you. Okay, but they might not know the in and out of Kubernetes. So because they are not supposed to know, they will depend on you. You will suggest them because you are an expert on Kubernetes. You will be you're being a DevOps guy. So you will suggest that, see, it is very vulnerable. HCD is the heart or brain, whatever you say. We must have it replicated. At least 3 pods of HCD should be running. If one goes down, at least we will have 2, support of 2. That way.
Okay.
Yeah. So we will have a deployment. See, this is also due to your deployment. Somebody has deployed. Well, you have installed Kubernetes. You have a deployment manifest, which has the YAML file, which has created the API server. So we do not need a duplication of or replication of this API server, scheduler, controller, manager. But at least the deployment manifest, which has created the HCD, that pod, will need to have a replica set of 3. Replica of 3. Minimum, if not less.
Okay, thank you so much for that.
Yes.
You can go right ahead, Mr. Ernest.
Alex. Mr. Debarsi, I was just making a small question, asking about the XCD, because I want to believe that it is a database, like you said, like it stores privacy keys and important, those important nitty-gritties. I just wanted to ask that since we're looking at a duplication in the duplicating the same structure in the slave drivers, seeing that we're speaking about cybersecurity, and I don't know, it is just a question. I don't know whether to say it's a question or a pondering thought in terms of what is it wise to also duplicate the XCD contents and the slave drivers, and if so, let's say what advice would you give us as newly inducted professionals in the field, like when we're starting or venturing into discipline, in terms of the duplicating those private keys on slave nodes, and what are the, if there are other I'd say exceptions, or I would say considerations that we must apply in the slave drivers, because I want to believe that what you do on the master node, there must be some I'd say robustness in the setup when it comes to the slave, the master and the slave relationship, in terms of those private keys being duplicated on the slave drivers.
Okay. First of all, very good question. First of all, everything what you do on Kubernetes cluster is in form of objects, components, objects. Better to say objects. Kubernetes objects. So when you say secret key, let's say a password or a connection details. So you are connecting to your database. So that details should not also be available. That is a secret information because database is where you are storing your database data, and that data can be very sensitive data, the customer's data. So you should not be able to access that endpoint from outside. So that connection details, the connection string should also be a secret information, isn't it? So let me tell you.
So are we speaking in terms of also encrypting it, or?
Yeah, encryption is definitely there has to be encryption. But when you store something into HCD, it is already encrypted. That is one thing. But you were asking that, okay, let me say, I'm drawing it over here only. Or I can use a notepad, whatever it is. So what I'm saying is there is a secrets object. You will create a secrets file that is also a manifest. An artifact, you can say an artifact. You desired some secrets to be in this. So secrets become an object where you can store your connection string, your passwords, encrypted keys like the SSL keys, whatever. So all these informations are very, very, very secret. They will be converted into an encrypted one, definitely, and be stored into there is an encoding. As a DevOps engineer, you can encode whatever the password can be encoded, your the keys can be encrypted, whatever the keys can be, even the your there are so many keys that are generated for security. Those will be stored in a secret file, and that secret manifest file will be maintained only on the master. And the master, and other than the API server, nobody can have an access to the secret. Nobody has an access to the secret. There is another concept called config map. Config map. This is a camel casing. So C is capital and M is capital because there are two words. Anyway, so config map is another configuration file which is stored on the master as an object where you can have your so many other things like the connection strings. When you connect to a database, there is the database username and the database password, the database environment, all these things, you can put that into a config map. Again, see, there are two things, secrets and config map. In the secrets file, you do not store the database environment, database keys, and all those stuff. What you do, that you put it under the config map. But
so, sorry, quick one. The desired state, is it the same thing as the secrets are you talking about? Is that what you refer to as desired state?
Desired state is the manifest. What is what that is what you desire. I will show you the deployment. Unless I show you, you will not understand what is that you desire. Whatever you desire, you put them into a declarative file. And that file is a YAML file. And that file is what we say a manifest file. Manifest file is an object that will be secured and securely stored. And that will sort of a daemon which is running in the background as a daemon. So our deployment, which has created our pod, will be running in the background as a daemon. So when it is running in the background, okay, of the master server, see this deployment is a manifest file. It will not be available on the slave. Please, somebody has asked me, there is a duplicate. No, there is no duplicate. You cannot have a pod running over the master of etcd as well as a pod running over the slave node. No, there is no duplication. It is called replica. Replica is not duplicate. Replica is a clone, such that if one pod goes down, if it goes down, you still have another 2 pods of etcd. You still have 2 pods. If another pod goes down, there is still 1 pod. So it can show the master is up.
Sorry, Mr. Debashish, can I just ask a quick
Yes.
question?
Yeah.
So if a replica is not a duplicate, right? Should we
Replica
just
is not
take
a
it? Should we just take it as an image?
Yeah, image. These are pods. Yeah, they are images contained in the
Okay.
container of the pod. Pod is an abstraction layer. I will come to that. But what I'm saying is, do you think that they are orphans? They are simply going down and nobody is taking care of that? No, they are not orphan. There is the controller manager. There is the replication manager controlled by the controller manager. So the replication manager will understand and know what to do in case of getting one pod which has gone down, to get it replicated back or to restored back. Because your desired state is 3 etcd, 3 etcd pods you have desired. Though you will not create the deployment manifest file for the master, because everything will be done when you install the Kubernetes cluster. Okay. So let's say it has asked for 3 etcd pods. I can know whether it is 1 running or 3 running. I will show that towards the end of our session. If you don't see it, you will not understand. Okay.
Okay.
So if my Kubernetes cluster installation had installed only 1 pod, then I am at great risk of my master getting down. Because see, if the etcd is down, the 1 pod which has gone down, let's say there can be some abnormalities, then the entire master will come down. Because API server does not do anything without consulting the etcd, but the etcd is down. So don't you think you need to have a backup of 2, a clone of one more or 2 more? And also you have to arrange something that if by chance 1 pod is down, so you make it back up and running. So the pod will be recovered, restored back. Because you have desired 3, you will get 3. What you desired, that is what you get. If it comes to 2, it will be restored to 3. If it comes to 1, it will be restored to 3. Because you have desired 3, that is the robustness. That is the there is, and also there is, there is a very, fraction of seconds when I could have demonstrated, but I usually do it in my main course, but there is no scope over here to physically show you that I somehow had make this 1 or 2 pods down, and how much time it took to recover it. It is very fast. I can watch. There is a watch parameter, watch option. I can give a kubectl command. The kubectl is the interface. kubectl. So with that, I can give an instruction that I want to watch the recovery, how much time it is taking, or this thing. You will see it is so fast. Even before you have executed the command, you will see that the pod has been replicated. So there is a replication manager. Controller manager is not the whole thing. Controller manager is one term, one broader term. But within the controller manager, you have replication manager, you have some other managers, so many managers.
Okay.
They have specific functions. So replication manager will not do anything other than replication. It's a very important term. See, your database should, the master database, sometimes there can be a hard disk failure, isn't it? So if the master DB goes down and you did not arrange to have a replication running between so there will be snapshots every few seconds that you have configured, so that that snapshot will take you, or will sort of will do the replication, or so not the replication. The replication is on. So whatever data is there over here will be replicated over to the other pods, which are. So, but if you had only one copy of this database, so what will happen if this goes down? Your entire application has gone down. So it's absolutely necessary to have replica. It is difficult to do everything over in a single session, but let me try. So what I'm saying is API server, this is a endpoint for Kubernetes service. As I told you, everything will point to this, come to this, and this is the endpoint for Kubernetes services, which gets exposed for controlling the various API services provided by the master node. Just give me 1 minute. So this is the endpoint of Kubernetes services which gets exposed for controlling the various API services provided by the master node to slave nodes. Pods control, deployment, etcd components, APIs, all pods information, etcd information access, all the pods IPs are registered to this endpoint. So all the rivers come to this ocean. So this, I can say this is the second most important component inside the master node. If anyone does any changes through the CLI Google Cloud Console, or if there are changes done through the Google Cloud GUI workloads onto the cluster, then all these changes are registered with the API server. As I told you, whatever the deployments that you are creating, whatever the services that you are creating, that manifest files, all will be monitored and will be under the purview of API server. It cannot implement any object without the permission, without the the management of API server. It has to be registered before you can implement. So we come to the scheduler. Scheduler is what? The scheduler takes care of scheduling of all processes and the dynamic resource management, and manages present and future events of the cluster. So it is a very important function as well. Okay, because you have to schedule if something has gone down. So it is, yeah, definitely API server will instruct the scheduler. Scheduler will go and use the controller manager to go outside the master and go to that particular node. And with the help of kubeproxy and kubeblade, it will make the replica up, make that pod up, create another pod, because you had asked for a replica. How it does, it is the magic. But we do not need to go into that details of the architecture, but you know that it is the scheduler which will, with the help of replication controller and all those things, will create the pod which has been lost. A scheduler manager scales up the pods. That is the scaling up, auto scaling. according to the application configuration demands on the fly. So dynamically it will configure. If you have desired 3 pods, you will get 3 pods, no matter what. That is, if an application running on 5 pods, so I have the same image into 5 pods. That means I have a Java application as an image, which is in a pod, in a container. Okay. And that I wanted to have 5 replica, such that if any one of the pods get down, my end users do not get impacted. They will still continue to access the application. So let's say there are 5 pods in a virtual machine, let's say in the slave. Can you have that pod deployed over the master? That Java application pod, that 5 pods, do you expect them to run on the master? No. A cluster cannot have only one master. It has to have slave nodes. Maybe one, maybe more than one. But even if there is one, all the pods will be deployed over the single slave node. Let's say you have a virtual virtual machine, and you have deployed 5 pods onto that, which takes 5 CPUs of RAM of 5 GB. So with a virtual machine is having 5 CPU and a RAM of 5 GB. And each pod is configured to have 1 CPU. So within the pod, you can desire, you can, as I told you, the deployment manifest file can mention the resources that is required for this pod. So let's say it has mentioned that this pod will require 1 CPU, 1 processor, and 1 GB of usage, 1 GB of storage. Okay. So for 5 pods, how many CPUs will be needed? There will be 5 CPUs. And how many GB will be consumed of storage? It will be consumed. The maximum will be consumed as 5 GB. But my VM has a total capacity of 5 CPUs and 5 GB. Now, suddenly, due to scaling up of the application, you needed 2 additional pods with the same configuration. So there would be someone who needs to look at that requirement. So will that single VM be able to cater to that requirement of 2 additional pods? Because how will you give another CPU, another 2 CPUs, and another 2 GB? So in that case, the scheduler comes into the picture. So it will look into that requirement of additional virtual manager to be created with the available resources to create these 2 pods is handled by the scheduler. Can you see the beauty of it? So a server was running out of resources to run those pods, and there was sudden requirement of, there was huge request coming in. So the scheduler can understand that this single pod, a single node will not be able to cater to that request. So we need to create another node or auto scale another node with at least 2 CPUs and 2 GB of RAM. Are you getting me? So that will be done by the scheduler. The kube scheduler component schedules the pods to the nodes in the cluster. So who will take care if the pod number of pod comes down from 3 to 2 to get it back to the number 3? It is the scheduler. Based on the consideration of the several health metrics of the nodes or the pods, for example, how much CPU, RAM available or storage left, and if there are any port conflicts. So all these things will be managed and understood and rectified by scheduler. Next is the controller manager. So the controller manager runs all the controllers on the Kubernetes cluster. What are the controllers? Node controllers. Somebody has to control the node through the controller manager. So the controllers are node controller, replication controller, endpoint controller, service accounts, and token controllers. So see, you are understanding that it is only one controller manager. No, the controller manager has sub functions. Somebody needs to control the node to understand whether the node is running out of resources. That you have to inform scheduler to schedule auto scale one more node, or to do something to distribute the load into the other node. So that is done by the node controller. The replication controller, what it does, it replicates, it manages the replication of the pods. Endpoint controller means something that you are pointing to the end of the service. So if for a specialized job, like to take your request to the particular service and to the particular node pod, is basically used with the help of endpoint controller. So there are particular functions designed for that. Service accounts. Now these service accounts are like Karthik was saying about the RBAC, right? Role-based access control. So that is a part of security. So you create service accounts as part of that role-based account control. And that is also managed with the controller called service account controller. And the tokens, the SSL tokens, the TSL tokens, whatever the project tokens, secret tokens that you create for security, there is an authentication token. Did you hear JWT? Java Web Token. It's a very they are working on this auth. It is called OAuth. JWT tokens are very I mean the modern or the latest for any Java applications. These tokens are very much in use because they are quite robust, and they are quite use of this in the applications makes your application very secured. So those tokens are, again, so there can be varieties of tokens, so many tokens. So they need specialized functions called token controllers to handle those tokens. Okay. So it is not only controller manager. So you can visualize controller manager is actually a manager which has all these components or controllers in turn. So controller manager manages the overall health of the cluster. It controls and manages the desired state versus the actual state. That is important. If our customer has a desire that I need 3 pods of Java applications to be running at any point of time, so that is a very important request, and that I cannot ignore. So I will have to maintain that. So therefore, the desired state will always be checked against the actual state in the cluster. And if there is a difference, immediately it will restore the desired state through the controller manager and the scheduler. Of course, everything will play a part, but mainly it is the scheduler through the controller manager. So kubectl commands are all processed and managed by the control. So what happens is the kubectl commands first hits the API server. Okay, API server will give those commands to the controller manager, and controller manager in turn, see, that's why the controller manager is over like an interface between the master node and the slave node. Now coming to the slave node components, this is the slave node components. Okay, we have the most 2 important part is the kubelet and the kube proxy. Can anybody tell me what about kubelet? Why kubelet is so important? You are talking about the slave node. You have left the master plane or the control plane. The other day I have said that kubelet is the manager of the pods. The pods are the applications which are running inside the worker node, slave node. So kubelet takes specifications from the API server and ensures that the application is running according to the specifications which were mentioned. Each node will have its own kubelet service. It has to have, because the kubelet will take all the information from the API server. API server will know all the information from the deployment objects or the service objects. Okay, There are so many objects, Kubernetes objects, and that will be provided to the kubelet. In turn, kubelet will check the health of the application running. So if any pod is getting down, the first hand information is available with kubelet. So it is a very vital function. So I can say that this is the agent. It must be running on each and every slave node. It should not be your installation should take care that you have installed kubelet. Okay. It is the component on the worker node. It monitors the activities in the worker node and communicates the health of the node, of the pod, to the master node, and more specifically to the controller manager. So it will hand over the information of what is the state of the health of the nodes and the pod, node and the pods. It will hand it over to the controller manager. Controller manager will take it to the API server. API server will check the information from HCD. HCD, then it will, the API server will ask the scheduler to do accordingly. This is the overall flow. Kubeproxy. So what is kubeproxy? Somebody? Okay. So kubeproxy is the network interface between the master node and the slave node, as well as between the master node and the external request or external whatever request coming from outside. This proxy service runs on each node and helps in making services available to the external host. It helps in connection forwarding to the correct resources. Very important, because it works on the pod network, and the pod network works between across all the nodes, between the master and all the nodes. So it is you can say that internal load balancing can be done with kubeproxy, because it understands over the pod network which pods are busy, which pods are not to be disturbed, or which pod are distributed to which nodes, and therefore I will forward the request to that particular node, because right now this particular node running this pod is too much heavily loaded. So it is doing some primitive load balancing. If not all, but at least some sort of load round robin logic of distributing the requests over to the pods will happen through the kubeproxy. Kubeproxy enables port forwarding of the services, because finally you have to discover the application pods which is running. So somebody has to take it to that pod. The services will take. Yeah, service knows which pod the request is asking for, but the service cannot take the request directly over to that pod. It needs the help of kubeproxy. You can understand in simple terms like that. Kubeproxy is nothing but a network component of the cluster. Deployments created and exposed as a service is possible for the kubeproxy. So deployment has created the pod and it has been exposed through a service, but the service cannot work without the kubeproxy. It helps in exposing the services around the nodes and the pods. So question: what happens if the master node gets down on the API server component, or the API server component crashes? Will the applications running with the pod stop running? Just read this question. Before that, to just complete that, there is a container runtime engine, or CRI. CRI means container runtime interface, or open connection interface, OCI. So Docker or Rocket or Mesos, whatever it is. But generally we are using Docker. We will install Docker. So that is a container runtime is needed to run containers inside the pods. Docker is the most popular container runtime engine inside the Kubernetes worker nodes. In fact, Kubernetes can use any OCI, Open Container Interface. Open Container Interface runtime space includes. So it can use Rocket, it can use Mesos, or it can use any other container, Open Container Interface. So the Docker does not come as a default container engine. It can be any other container engine other than the Docker. So this is for our understanding that we always refer to Docker, but it is not necessarily that it has to be Docker. But the question is, what happens if the master node gets down or the API server component crashes? Will the applications which are running on the slave nodes or on the pods stop running immediately? What do you think? What could be your guess? Without the master node running, will the pods be still running on the slave nodes?
No.
No. Anybody, any other answer?
I would wonder, based on how I understand it, I would wonder
Yes.
if the pods are healthy, there shouldn't be a reason why there should be communication with the master node. Unless
Fantastic.
one of them fails, and then there can be communication that okay, and then there will be that error that there will just be two pods left.
Correct. Yes. Yeah, absolutely correct. Because if all the pods are running and they are healthy, the kubelet does not report anything. Okay, even if the master node, the API server is crashed and it is down, that communication does not happen between the kube proxy, so between the kubelet of the node, of the slave node to the API server. That is fine. But that does not necessarily mean that the pods will immediately start running out or dropping off. No. If it can run on its own because it is running on a separate server. It is running on the slave, which has its own processing capabilities. It can still continue to run the pods without any issues. Yeah, the issues will start coming on if, say, one out of the 3 replicas of the pod, one pod has gone down. Will it stop? No, there are still 2. Yes, the third pod was not recovered or restored. There was no replication of that. Fine. Another pod gets down. So how many pod left? You desired 3, but now remember the master is down. So there is no scheduler that can scale up 2 more pods immediately. So you are left with 1. Now still your pod is that 1 pod can still keep on running. No issues. Yes. If at any moment that pod gets down, then there is an issue. So your application will come crash. It will be crashed because there are no pods which are available to running the applications. So the requests will all fail. Internally, what happened? Because it cannot pass that information to the master node because master node is down, or the cluster, the control plane is down. So therefore, there is no way to recover those nodes or replicate those those pods back. In that case only it will crash. Otherwise it will keep on running if it can run. So the answer is no. As the worker nodes and the pods continue to run, though no changes to the node and pod configuration can take place unless the master node is made up and running. If you wanted to change anything on the slave node, you need a master node to process your changes. If that is not available, it will not. But if there are running nodes and the pods continue to run, there is no impact. So a pod. So what is that pod? You see, there is an application, there may be a Java application, and there is a container. So this application is within the container, and you have the pod. So a pod is an abstraction layer made on top of your container. Because basically the container does not have an IP address. If you have learned Docker, You will see when you create a container, you will create a container with a port, container port, but that's all. You do not have any IP address. So how will one container communicate with the other container? That is a bit difficult thing. Okay, so you need to have a cluster, and then you make a layer on top of the container which has the capability to have an IP address. So this, think of a pod having an IP address which can communicate with the another pod having another IP address. Is it not? So which one is better? A container without a pod or a container having a pod? Because then the communication between the pods, the microservices have to communicate. This microservice, let's say this is the login application and this is the login database. So both of them have to talk to each other. How will they communicate? They will communicate over the IP. But then, so what is a pod? Pod is the smallest unit of Kubernetes cluster. Pod is an abstraction over container. So there is an abstraction. There is a abstraction is something which is, you say abstract. You cannot physically conceive it or perceive it. But it is a logical abstraction over the container. Usually, I will have one application per pod. It is the thumb rule. You should not have more than one application inside one pod. It is not preferred. Each pod gets its own IP address. Yes, you can see IP address. And if a pod gets down and replicated, so will the IP address remain the same? So the replication manager or the controller manager with the help of scheduler has created back the pod. A new pod has been replicated because your earlier pod has gone down and it has made your desired state from 3 to 3. It was down to 2. But do you think that the new pod that has been created as a replicated will have the same IP or different IP? It will sorry?
I was thinking if it's a replica, then it should have the same, but if they are not replica of the old one, then it might have a different
No, you say replica of the pod. You do not say replica of the IP address. IP address is a means to communicate between the two pods. So if you have created a new pod, the IP address will not be the same. And if the IP address is a new IP address, it is natural. It cannot be the pod does not replicate the IP address, or the deployment does not replicate the IP address. How can it? IP address is automatically assigned because otherwise there cannot be a communication between the IP address. But that is a big problem for each pod getting down and a new pod replicated with a new IP address. So you see the configuration. So this pod knows the earlier IP address to communicate with. Now again, this has to be internally configured, switching over to the new pod IP address. So someone will configure it internally, but then that is a, it can be performance issue, it can be a time consuming thing, or it can be something which may not be handled efficiently. And the communication does not happen that smoothly because every time it has to readjust the communication. That means the old IP address is no longer available, so I have to replace it with wherever that pod has to be readdressed with a new IP address. So that is a cumbersome process. So IP address will now be replaced with a service. A service is a permanent IP address. That is a big advantage, a big jump over this. So the Kubernetes has provided a service object. You can create a service object. You can apply that into your pod. So even if the pod goes down and a new pod created, your service IP address will not change. So don't you think that is a big advantage? And you can communicate between the pods using the service. internally. And a service can communicate with the external request to take you to that particular pod, because each and every pod can be labeled, and this service will now understand that there is a label and I will have to go to that particular label because to that particular pod because I was asked to go to that particular label. Any question that you might have? You can go through all these slides will be available in our site. So you can still have those. Okay. So there is a replication, and you see that this is the master MongoDB master database, and you can do a replication of having 4 more pods. So if this one gets down, another pod will be replacing this. So it will never go down. So now you can say what happens if the master, how is the data, because database replication is a different technology. There is a snapshot every few seconds. There will be a snapshot. See everything. Everyone will be interacting with the master. That is the master database, the master pod, database pod. No one will directly interact with this. But every few seconds there will be a snapshot of the data, incremental snapshot you can say, and that will be saved over all the pods. That means at any point of time, whatever data you see, let's say you have 1 million data, and at that point of time, you will also have 1 million data over here. Same data. Because every few seconds, there will be a replication. And now you will say, what happens if the master database goes down? No problem, because the same data is replicated over here. And also you can be rest assured that you're immediately during the say, let's say it took a fraction of a second to get the master database back as a replica. But that fraction of second also few people have put in some data. There was new data created and everything, but all these things will happen within fraction of seconds, and it can replicate back when with the new pod, with the new master, it can replicate back the data. Again, a reverse snapshot happens. That means the data which was stored over here will now be flushed into this one. So there was an object called replica set, but the replica set worked on the selector, and these are the various terms, you know, in Kubernetes that we do not have a scope over the internship to discuss detail on that, but there is a selector and a label. So each pod will be, each replica set will be labeled. Replica set is an object which, with the help of which you can have a replica, the number of desired replicas that you wanted. Okay, so it will maintain the count of the desired number that is done to the replica set. But we come to this next slide. So why we use deployment and not the replica set? Because a deployment is a higher level concept that manages replica sets and provides a declarative update to the pods. Along with a lot of other features, this deployment is a new thing that has come after Kubernetes version 17. Before Kubernetes version 17, you used to have replica sets and you will create pods using replica sets. But nowadays, we do not use replica set, we use deployment. Deployment manifest, through the manifest file, we deploy the pods. We create the pods. Deployment is what? Is provisioning. So we have replaced the replica set with deployment. Therefore, it is generally recommended to use, because deployment have a lot of features, much more flexible. And you can declaratively create your deployment. That is, you can declare your what? You declare your desired things that you want to desire. So there is a brief comparison. Replica set ensures that a specified number of replicas are running at any given time. However, a replica set does not support a clean rolling update of an application. So as I was saying the other day, there is a blue-green deployment. That is, you want to deploy without any downtime, because Amazon or big companies, Fortune 5 companies, do not afford to lose even a minute, a downtime. Leave aside, when I used to work in IBM as a project manager, I used to have a deployment of say 3-4 hours deployment window. That means during that 3-4 hours, we have to fight with our clients to get that deployment window, because we could not have, we cannot deploy a new feature into our existing product without getting the running product get down or shut down. So within that deployment window, we will manage to deploy the new feature, test it, and then if it is stable, then we will open it for production. But that is not a desired thing at all for today's customer. If you ask for a deployment window, they will say, I will charge you. The loss that I will incur during that 1 hour window time, deployment time, I will charge from you. So can IBM afford that? Or can any vendor afford that? So better, I will use the deployment feature of Kubernetes such that I can make rolling updates, a strategy called rolling updates. Fantastic. You can seamlessly deploy your new feature while you take down your old feature or the old product slowly, gradually, without the customers who are hooked into your system, logged into your system, they will not find any difference. So deployment is very important. We will use deployment to create our stuff. Okay, so what is that? So can you see a container where your image is running, your application is running inside the container, and you have an abstraction layer on top of the container, and that was done by whom? That was done by the deployment manifest. And the kubelet will communicate with the pod over the pod network. Okay, so what happened in the basic, that application, that image is running inside the container, and then with the help of deployment manifest file, you have created a pod and surrounded or created a layer, abstraction layer over the container such that the pod will have can be exposed through the service that you attach to the pod. So there are lots of things. So better to say that I have used a deployment manifest file to create 3 replicas of the pod. That means the same application, let's say Java application is running inside one pod, but I am not happy with one pod. I have done a replica of 3. So those in desire, what you desire will be mentioned in the deployment manifest file. You can also declare the resources, that this pod is taking this much of CPU, this much of RAM, this much of storage. All these things you can declare within the deployment manifest file. So you can understand that deployment is a Kubernetes object created out of a manifest file. With the help of deployment, you create pod, and the pod will surround with a layer on top of the container. Container will have the application. So you are running an application within the container, within the pod, with the help of deployment manifest file. So as I was saying, that you want to access the pod, how will you do? You have to hit the service. Okay, the service will take you to the pod, one of the pod, of course. So service can also be some sort of a load balancer, and there is a load balancer service. There are 2 types of service. Okay, you see, every pod will be assigned a service. So service is also a manifest file. So you attach a service to the deployment. You can say a deployment is followed or attached with a service such that the pod will be given a label, and the service will try to select with the help of selector to go for that particular pod using the label. So there can be external service called the cluster IP and the internal service. The internal service called the cluster IP. Service name is cluster IP type. And there is an external service. You can have an external service called node port or ingress controller. That is a bit advanced concept in Kubernetes. This is out of my scope to discuss, but I think we can see how would the service or the ingress. So as I told you, there will be an ingress. So instead of service, think that there is an ingress controller, which is also a reverse proxy, which is also a load balancer. So load balancer will hit the service through the ingress rule, and the ingress rule will take will get hold of the service, and the service will take. So this is the complicated way of workflow, and it has to be complicated, not simple, straightforward, because otherwise you are breaching the security needs. You have to protect your data, which is running as a database application. So you cannot directly access, this guy cannot directly access your data simply as that. So I will never use external service. If I have to use external service, I will use ingress controller. Through the load balancer, it will be filtered. The rules will, if you are not obeying, it is like a security group. You know, Karthik was discussing about the security group, how you filter the initial request. So if the request is coming with a particular device, as well as the device is whitelisted or blacklisted, so it will not, if it is blacklisted, it will not be allowed. Even if it is whitelisted, but if it is not following certain rules of connection, it will not be allowed to get. So similarly, we can implement that external service as ingress controller, which will in turn, it will go to that. Through the labeling, the service will be able to identify so discovery of the pod is one of the hottest topic, you know, how to discover a pod out of hundreds and thousands of pods running in an environment, how to go and hit the pod correctly and within efficient time management. So all the IT, whatever discoveries are happening nowadays, all the deployments and deliveries are around this. It's a hot discussion. How to navigate the service mesh. Service mesh is a very important topic. As you learn Kubernetes, you will come with your advanced learning of Argo CD, GitOps. All these things will take you, the technology will take you how to fast discover your application. Kubernetes is one of them. So whatever it is, now I'm not going to that much of details, but you have to discover the healthy replicated pod. It has to be routed to the correct pod, to the healthy pod. And it is doing the labeling that was created during the deployment of the pod. That is one part. I know I'm rushing through the topic, but yes, I have to do that. So you see that there is, you see the architecture. This is a very important picture. Okay, so let's say you are a user. Okay, and you are using a browser. And that browser is using a URL. URL is a uniform resource locator. You want to locate a particular service or a particular application. Let's say you are using Netflix. Let's say this is a Netflix application, and you want to go and hit a particular video, some movie. You want to see a movie. Okay, so what will you do? You will, through some application, you will go through the Netflix application will take you to that particular movie. That's fine. But let's say how it is internally getting worked. So you give the endpoint. The endpoint is the API. the REST API, better to say endpoint, that you want to go to a particular movie or a particular video, and that video is lying in demo.com. That is the domain name, DNS service, or a particular domain name. Let's say we have exposed few of our applications over the Kalkey.com. So Kalkey.com is the domain name, because in that case, we are hiding our IP address. We should not expose our IP address to the external user. This user has nothing to do with our IP address. What will it do? And also, if that user is a hacker, so he should not be able to get access to our IP address directly. So that demo.com is a domain /video. Now that is the endpoint, or that is the API, REST API. So that REST API, but then before coming to that, I will hit the ingress service. That service is either a load balancer or a node port service. Load balancer is not the physical load balancer. It is the service load balancer that you configure over the ingress. Now that service comes when you install the ingress controller. You have to install it, because with your installation of the Kubernetes cluster, you are not installing the ingress. Ingress is an external tool that you have to install. And within the ingress controller, the most famous ingress controller, can anybody name it? I will give a hint. It is the reverse proxy web server, one of the famous reverse proxy web server. So to save your time, it is Nginx. Nginx is one of the most popular reverse proxy server, web server, and also it can act as a load balancer inside the ingress controller. So when we install Nginx ingress controller, we are installing a pod which is running the Nginx web server. Okay, and that pod will be accessed from this service, which is a node pod or load balancer service. What is that? A ingress service. So that Nginx will take you, or the ingress controller through the Nginx will take to the ingress rule. So you cannot directly access this server. This person cannot directly go and access your application, your video. It has to traverse this path, this route. That is the beauty. And here the actual filter will happen to discover your particular thing. You have given a correct identification. So that rule says that this is the path. And if this is the path, then you will hit this service, not this service, because this is a music, image. There can be another domain or the same domain with a end API called music. So you want to hear only the music or music videos. This is the movie videos. This is the image, the photos, the static photos. So these are the various services. So when you try to access the video service, you will never hit this service, because your ingress rule through the ingress controller will hit the cluster. Cluster IP is the internal service that I told. You cannot go through the external service like node port over here. This is inside the cluster, so it is an internal service. Your internal service will take you, because internal service is a very safe way of getting you to the pod, because it is only this service that knows. But how are you coming? So you are coming like this, going like this, hitting this, or going like this. So if your rule, that is the API endpoint that you have specified, does not feature in the set of rules that you have designed for your application, then it will never reach any of your application. We say that this is ingress API object, that ingress controller. It's a very interesting subject to learn and to know. So you are going to get a domain from GoDaddy, or Google Cloud DNS or AWS Route 53. Route 53 is a very popular, domain name service or registrar, because you cannot design your own IP address. You have to, if you are going to work like Kalkey.com or any domain, Google.com. So that will be given a domain name as well as the IP address that will be converted into a domain name. With if you go by GoDaddy or Cloud DNS or AWS Route 53, and therefore you can implement that. So therefore, what is happening? You are hitting this api.example.com, that is the host. You are not exposing your IP address. So this is the domain name / payment. What is payment? Payment is one of the service or the endpoint that you desire. Okay, and the payment will take you to the payment service, which is the backend, which is the database maybe. But you do not mention payment service. You will be given an endpoint called payment. So with the help of this, if your API, if you have an access to this API, if you're registered to this domain, you can hit this application called payment service, payment gateway. And also you can hit your authentication service. So these are the endpoints through which the ingress rule will take you to that particular service. So if you are looking for authentication service, you hit this service or this ingress controller, the Nginx pod. You see, these are the Nginx pod. And also the Nginx pods are replicated. There won't be only one Nginx pod within the Nginx controller, ingress controller. Okay, so there will be several pods, such that is why it is called a load balancer. You can, there is a heavy traffic coming inside. It will hit the ingress controller. So ingress controller should also have a capacity to handle that traffic, that huge traffic. So it will also use Nginx as an load balancer to distribute the load between the applications. So I know it is too much for you to grasp in a single session like this. But you see, this is, somebody was asking me, this is Nginx deployment. This is the name of a YAML file I have given, and within this I have given my instructions or declarative. This is a YAML structure. YAML is based on JSON. JSON is JavaScript object notation. You see, whenever you find something like key : value, this is a key value pair. This is a data representation over the internet. Earlier, we used to work with XML as a format of data exchange within the, that was also very safe, but that was very cumbersome. For a single data to be passed over to the internet, I have to write a big XML file. Whereas here, it is very, very simple. So on the left hand side is the keys. On the right hand side is the values. So somebody was asking whether the API server is an API call. Yes. So that API is the API version of whatever. We will use the apps. So deployment is an app, and you can see a service. You are saying that this is one manifest file. You want to say kind deployment. So this is a manifest file for deployment. What does deployment do? It will create a pod. And the name of the image that you are downloading from Docker Hub is Nginx. So the Nginx application, so the image name is Nginx. And the container, the image is Nginx, and you are naming the container as Nginx. So fine, you can give any name. Name does not matter. But this is the application and Nginx. That is the image that you are downloading. So you are giving a label to this app called Nginx. So the pod has a label. Basically, you are specifying, you are giving the specification within the template of the deployment. So the deployment specification says that you want, can you see replicas? I know you are not responding, but can you see replicas? So you are mentioning that you want 3 replica of this pod Nginx. So I will have 3 Nginx pods. If I have applied this manifest file. So, but the pod should be attached with a service. So what I'm doing, I'm creating a service. API version is version 1. And I'm giving a metadata name to the service is Nginx. And in the specification spec, I am giving that it will have a port and there will be an internal IP address for the, and there will be a permanent IP address for the service as we have discussed. But at the same time, with which pod it has been attached, it is declared with the selector. Can you see? So the selector will have that label. That label of the pod was Nginx. So you are actually selecting this particular pod to service. Are you getting me? I'm not sure whether you will learn it, but this is how you do it. So thank you very much. I know it is not possible to learn Kubernetes over a day. It will take long hours of rigorous practice and understanding. But I have a time constraint, so I will stop the discussion over here. I know there are only few people, but these people are very important people for me because you have your patience to continue with the session, and I thank you for that. It is not much to the liking of many people because they find it too difficult, but I find it very interesting. Okay, and you will find it very interesting because that can fetch you a very good job. Kubernetes jobs are highly paid jobs. So don't think that it can be easily achieved. You have to give in some effort, but I'm sure with a very good mentorship and a very good guidance, you will be able to pick up Kubernetes within, say 7-8 sessions. That is enough. So thank you very much for all your patience, and we will end the session over here. Okay, this is the end of the second cycle of our Kubernetes, DevOps internship. So maybe after a gap of 1 or 2 weeks, I will again come and bother you with another cycle starting from AWS Cloud. Any questions you have, please? Otherwise, I can stop the recording and we can say bye for the time being. So I'm stopping the recording right now. Oh, did I not start the recording? I thought I started. I don't know. Oh, there was a network issue that took away the recording. Anyway, I think my friend has already done a live recording over the YouTube. Is that true, Shubhro?
Yeah.
Thank you very much. So again, mishap happened over this session as well. Anyway, but I distinctly remember that I have started, but somehow there was some network issue and I was logged out, and therefore after I logged in, I did not notice that it was not running. Anyway, no worries. This recording will be available within a 1 or 2 days. Thank you. Thank you. Yeah, Alex.
I guess I was just wondering, does the main course rather, does it include a hint of Kubernetes? Because it is interesting. So
No, not hint. the full Kubernetes.
Okay, so is this for the main course? Because I do recall that I remember there were levels that in the main course, what we're gonna learn is mainly the fundamentals and how to apply job-ready skills of DevOps, including Docker. I was wondering if we're gonna be introduced also to Kubernetes so that
No,
in
we
learning
have a
Docker.
full course. In the full course, we have uh, lots of labs and
Okay.
things on Kubernetes. Yeah, definitely.
Okay,
We
awesome.
covered because earlier, say even one year back, we didn't have Kubernetes in our structure, in our course structure, because at that time the recruiters were not asking our students any questions on Kubernetes. So we thought, okay, maybe they are happy if the persons know DevOps, maybe fundamentals very good and advanced as well. So our course was designed like that. But
Okay.
another, say, 1 year later, we found that no, they are asking on Kubernetes, and many of our good students could not crack the first or second interviews where they were asked about Kubernetes because they didn't know. So we then introduced. Earlier, our course, our hours were 2 hours per session, okay, and that was 60 hours. Now we extended it to 75 hours, 2.5 hours per session, because we could not extend 1.5 weeks or 1.5 months. That is 6 weeks, because more and more we do that, more and more the students lose patience and they can drop off. Therefore, to keep the attraction intact, as well as I include more and more into it. So I extended my session from 2 hours to 2.5 hours each day.
Okay.
So
Brilliant.
I could accommodate 75 hours within 1.5 months. Though I am practically, I will say frankly, I can with any of our batches, after we have introduced Kubernetes, I could not complete it within 6 weeks. It took me almost like 8 weeks to complete. That is natural, and I natural, because there are so many things to know, because these are around 7 to 8 tools we learn. It is not that simple. But I do not scare my students. My students come from various backgrounds. Okay. Mostly from the non-IT background, from commerce, from accounts, or they are project managers or some sort of managers. They don't have, they can manage, they understand, they have a good IQ, but they are not particularly into IT. But those students, they start as non-IT, but they become quite good. We are also surprised sometimes that how can this person, because out of their own interest, effort, and with our some guidance, they transform themselves. That is, it is really motivates us as well. Sometimes, we are doing a lot of good things with people, because think of them, if there was no DevOps, they would have to go for, they had to go for learning development. And in the development, how will they cope up with this? This is a saturated domain. There are so many good developers. Everyone is a developer. So they stand no chance at all. It is very sad to say, but that is reality. They never get a chance. So how will they get an entry into that IT domain? This is the best option. Come through DevOps. Get acquainted to IT. If you are capable, you can go to the DevOps advanced concepts. In my documents, in my course structure, we have the advanced topics as well. So if you are not capable of do the advanced things, fine, but at least know the fundamentals. Because you are, after all, going for an interview at the entry level. There are lots of opening for that. But yes, now the interviews are getting stiffer and stiffer. They are asking questions from Kubernetes. So the concepts should be very, very clear. I have found that those people who have even with a non-IT, but they have a logical bent of mind and they can think out of box and the concept wise they are very clear. Those people excel.
Mm.
So I think if you do not have any further questions, we can end the
Yes,
session.
thank you, Mr. Debashis.
Yeah, sure. Thank you. So I will stop the sharing.